Okay, hello. So it's been a couple days, and honestly been low-key slacking on it. But I wanted to do this new format where I spun the wheel. So, I mean, I know it's either gonna be greedy or dynamic programming, but I guess it'll help me with my like pattern recognition. So, I'm actually filming on my iPad, which is connected to my MacBook. So, yeah, I guess I'll spin the wheel, and then we'll see what problem we get. Okay, it's on read code. Okay, let's see this problem. Oh, I've already done it. So, yeah. Okay, off the rip. I know it's gonna be greedy or dynamic programming, and something I've learned, or I remember from learning, is you should always try to do greedy, first, and if it doesn't, if you find a case where like being greedy makes it, um, like not possible to create a longer increasing subsequence, then you should just do DP. So off the rip, I kind of can see that it's DP. I mean greedy because well, hmm, let's see. Yeah. Okay. So mm, yeah. So for this case, I'm writing with my Apple Pencil, so the handwriting should be a little bit better. Okay. So the weight though. Um. Okay. I guess greedily, what would be the greedy choice? I think the greedy choice in this case would be like, um, well, since it's increasing, so let's say we have um, this as our subsequence. What? Well, actually, that wouldn't make sense because it's not increasing. But um, yeah, let's have this. What is that? If this was our like previous one and we were here, right? I guess. Hmm. Well, okay, no, look. Um. Hmm. Well, I guess we can kind of just rule out it being greedy because if we just started and we took this, um, took 10, it would make sense to take 10 because it's, I mean, like taking something, like if we're here and we have the choice of being able to take something and not taking it, we would automatically take it. So so now we've taken this 10, and now we have a 9, which is less. So I guess like the greedy choice would be just to reset, like restart our um like our subsequence, because since 9 is less than 10, it has greater chance that there will be like let's say we find a 10 again, um since the subsequence has to be strictly increasing, then it's more beneficial to take a 9. So we reset again, and then we're at the 2, and by the same logic we take it, and then we take the 5 because it's bigger, and then we find this 3, and then we take this 3 and this 7 and this 108, and then we have this 18 that's left. So our max one would be 3 here, which is incorrect because the longest one is 4. And basically Yeah, I guess. If that makes sense. Like we can't be greedy because just because there's a next like a number we can take doesn't mean it's like automatically a good number to take. Like in this case, this 5. Um, if we take this 5, it means we can't take this 3. Um, actually, yeah, which means we can't take this 3. Yeah. Like, yeah, if this was like a 6 instead of a 3, then we could take it and then we could get this. But like in this case, we can kind of see that like we can't greedily pick our um, numbers because, well, our kind of example is this case where we pick the 5, and in the case we didn't pick the 5, we could pick a better sequence. So that points me to DP. But how would that look like? Um, so, I mean, okay. Um, I mean, this starts at 1, right? And if we were in this position, you would look left. Left here, or wait, I'll just put like a 0 here. Yeah, so our DP array, well, I guess our DP array will be like at this index. What is like the max length? I guess we're trying to maximize our length of the subsequence, right? So I will just move that. Oh, I'll move that there, right? So this will DP of 0. Wait, so this would be I. 0, 1, 2, 3, 5, 6, 8. Yeah, and then DP of 0 would just be 0. DP of 1 be 1. That's our base case, right? And this 9, um, it could be that we can take this one if it's less than, or we can, if we skip this one, we can take this one if this is less than this number, right? I feel like that's how the DP would work. So let's just go with this. Or like, or would it be that yeah, it's either you include this 10 or don't include the 10. And I guess for this case, it's best to, well, it's not even like greater. So we can't even, that's not a choice we can make. So it's either we skip this 10. I mean, either way, we kind of skip it because, wait, no. Well, one case is if we take this 10 and don't take this 9. And then the other case is we take this 10, skip this 9, I guess. Wait, is that what I said before? Okay, I don't know. Okay, so if we're at 2, this would mean, so actually, I don't know. I don't know about this. Is this the right way of I feel like DP is always easy to think about it backwards. Okay, it's either we take, oh wait, no, we can't even take these, so the best we can do is 1, right? And then 5. With 5, we can either, okay, no, wait. So up to this point, 3, the best we can do is sequences of 1, I guess. And this 5, when we're here at this 5, we can look here at the 2, and if it's greater than the 2, it'll be the max of, yeah, no, it would just be that plus 1, no? So this would be 2. No, but then you would have to go back here and then check here and check here. So how do we not do that? Because when we're at 3, I feel like it's so much easier to do it top down and then change it up. So oh, this is probably a bit too big. So we're at 0. We can either, so I guess this will be our Kermax. 0. Don't take. And then, so like length 1. This one has one choice, which is to not take. And then this would be, so we have 2 choices here. We can either take or don't take. So it's either 9, 1 or 0, 0. It should be 0. And here we can either, yeah, and then we can just keep taking or not taking. Wait, okay, so, well, yeah, well, it kind of just follows this decision tree. It's if the one before it, if we're greater than the one before, we just add to it. Otherwise, we don't add to it, and then we have a choice of either taking, like, starting a new path or not starting a new path. Yeah. Right? But in this 10, yeah, okay. I feel like my explanation is not very good, but I'm just gonna code up the solution to how I think we can do it. So it's kind of hard because I'm looking at my iPad, but I'm typing on my MacBook. Okay, well, I'll just do top down because it's easy. So we have our current index, and then we have our max. Right, so if I equals n, return 0. Okay. Okay, if I just do like this, so it's, you don't have to check if I minus 1 is in bounds. So okay, the res will be the DFS if we just skip it. Right? And then our max. But if num z I is greater than num z I minus 1, then we res equals something like that. Bruh. Nope. Oh wait, I think I know. This is 1 plus. I don't know if that's... Is that right? No, okay, I think it's isn't it just when it's here? 1 plus this. What's wrong here? Oh, it's because there's no way for us to skip this number. Oh, maybe we have to look forwards then. So, oh. I have no idea. Am I really this rusty? I mean, we're kind of picking it like one after another. It's... You can't really like... Okay, what about this? We keep this. Okay, how about this? For j in a range starting from I plus 1 to n, right? If nums at I is greater than nums at j, greater or equal actually, then we continue. Otherwise, if it's greater, between res and 1 plus nums of j. Alright, so we're here. Now we can pick any of these. We can pick that. Oh, we actually can't pick. We'll only go to that. And then, oh wait. 1 plus x. If we skip this number. Huh. Well, let's see for 2. So if we're at 2, we can go to 5. It's possible. And then we would, from 5, we would only get we're not counting what itself, is it? Like, if we get 2, we're at 2, and we're at number 2. We go here, 3. What's going on this one? How can we get 4 from this? Four. maybe this needs to be the one. But that doesn't make sense to me. It's off by 1. If we're at index 4, 0, 1, 2, 3, oh. Index 3 is 3. Wait, no, this doesn't make sense. Wait, yeah, no. Wait, no, that makes sense. Because we're including the I in it. So this? I really don't know what's wrong. It feels like I'm so close. Zero, 1, 2, 3, 4, 5. Okay, if we're 6, this should be 1. Okay. Then you have this motherfucker, bro. What? Okay, when we're at 3, it will be at 1 or to 2. So we're at R equals 2, res equals 2. Hey, let's look at the memo, bro. 0, 1, 2, 3. So if we're at 3, that's 3. If we're 0, 0, how are we at 4? Because oh, maybe. Ah, got it. I'm dumb. Oh my god, I'm so dumb. Nah? Not that? How? How's it not that? Oh. No, because that's like the previous max, right? Bro, what am I doing wrong? Okay, let's see this, bro. Oh my god. Hmm. Oh, true. Cause this. Oh, that feels terrible. What is this? Bisect left. What? Okay. Okay. I think this is a hard problem then. Okay, I think I know where I messed up. Um, I think if we just add for uh, yeah, if we've been to this I before, just a max. Yeah, it'll be 1. That's our minimum. I think it's. Oh wait, no, you have to plus 1. No, why not? Oh, it's because this is already 1. I was thinking plus 1 because we didn't include the beginning. That. Oh my god. This is very, very slow. Wow. I don't know if this is even gonna accept. Yeah. Wow. Wait, whoa, what's different from this one then? Oh, this. Let's say this one. No, this one. Is this one even right? Yeah. This is exactly what I wrote. No? With some extra steps. Oh, oh, we don't need the max. Yes. But how come? Ooh. Are we just assuming that this J is the max? Oh yeah, that would make sense. Yeah. That's a hard one. Um, oof. That's pretty hard. I don't understand this bisection thing. Yeah, I'll get ChatGPT to explain that to me, cause yeah, I think I solved it, but I must have not solved it by myself. I feel like it's so it's like very simple though, which is kind of what makes me annoyed, because I think the thing I didn't get was that you could start at any place, and but I kind of did though, cause you could start at any place if you just kept skipping. But then I guess that max thing didn't. I don't know. I don't know. I'll try this one again tomorrow. I think I'll get it to explain to me. So Um, I'll actually, I'll remove that later. I'll remove it now, but I guess I'll do one more because that was pretty bad. Please give me an easy one. I don't think this is gonna be an easy one. Okay, now I'm actually have to test myself because, okay, Nick has N bottles of soda left after his birthday. Each bottle is described by two values, remaining amount of soda I and the bottle volume BI. Yeah. Nick has decided to pour all the remaining soda into a minimal number of bottles. Moreover, he has to do it as soon as possible. Nick spends X times um, Nick asks you to help him to determine K, the minimum number of bottles in T amount of time. Okay, so this is easy, hopefully. Bottle count store. Okay, we're gonna do greedy because well, ideally, right? Wait, uh, all remaining soda should be saved. Let's add number of bottles. Wait, what? Okay, let me do a little drawing, I guess. So if we're at 3, 3, 4, 3, 4, 7, 6, 5, that means we have capacity in one bottle 4, 2, and 2. Right? And that means we can just pour this one and these two into here. Wait, no. This has it has that much empty space, right? So we could pour this into here. And then we would have 6, and then we can pour these two into here. So yeah, just thinking about it. Oh, I don't know. I don't know. I mean, yeah. So I guess, right, we want to sort the amount of like how much empty capacity we have. So we want to pour the most amount of remaining soda into the bottle with wait. Um Nick can pour the first and second bottle. It'll take 3 seconds. First takes 3 seconds. Then he can pour soda from fourth bottle to the second bottle and third bottle. Oh, what? Okay. So, Oh, okay. I kind of get it. Um, mm, okay. So we have. So we want to sort it by like empty. Oh, what did I just do? We want to sort it by empty capacity, right? So, um, where's my pen? Where did my pen? Where did my pen go? Ah! I just stopped my. Okay, here, found it. So, um, I guess we want to, we start by like the biggest, um, okay, the most amount of like empty, like like available room, right? And then the second ranking will be like, if they both have the same amount of capacity remaining, like this, I guess it makes sense to sort by the size of the bottle, maybe? Because otherwise you have to pour this like 4 into here, which doesn't really make sense, like, because, I mean, like, ah, mm, I'm not too sure, to be honest. I mean, we want to, like, we want to try to fit everything in like the two big bottles, right? So like the amount of remaining soda is 3 plus 3 plus 4 plus 3 will equal 13, right? So, and then with the bottles that we have, we want to minimize the amount of bottles we have. So obviously pick the bigger bottles, right? And then we just want to, yeah, and then we just have to see like how long it takes to fill up each bottle. So this will take, I guess it'll just take like this minus what's inside, because whatever's inside you don't have to pour into it again. So it'll just be these, whatever this is. So, okay, my game plan. Okay, this is the game plan. Okay, so, okay, so we want to find big bottles. Well, okay, for first we'll find the sum of everything of remaining, right? And then the game plan is we'll um, find enough bottles to fit this capacity, right? And we're picking this greedily because what's the point? Since we're trying to minimize the amount of bottles we use, we can just pick the bigger ones. Because why would you pick a small one, right? yeah, so find bottles greedily, right? And then we'll minus uh, so minus max cap, because um the capacity could be bigger than like what's needed. Like um it might be that one bottle is enough, but two bottles is exactly what you need, but there'll still be some room left at the top, right? So we'll minus the maximum capacity by our sum, minus sum. Wait, no, by what's in the bottles, right? Minus in bottle, right? And then this will give us a value where we need to like pour, and then that's our T, and that's it. That's honestly it. I think it's pretty simple. Um, yeah. I think it'll take like n log n time though. Okay, I'm going to pull up my VS Code. Oh my god. Okay. I think I just closed it though. Terminal. Okay, what is this problem called? It's a really long name, but I'll just copy paste it. I think that took me really long though. I feel like the answer is pretty simple. Okay. Put this. Okay. So first we're gonna import system. If solve. So input data. That will just be the system. Well, sys.standard in dot read dot split. Yeah. And then iter it equals iter what's my input data. Then rn for int x did it backwards. I don't know if it's actually necessary to do that. Yeah, so Rn is that. So R remaining. I kind of want to like zip these together. Remaining equals bottles. Then I don't know how like to zip them together. I guess I kind of want to like pair them up, right? So I'll just do that like this. For for I in a range of n, pairs dot append. So it will be the amount what we want to maximize by the bottles at I, and the remaining at I. Yeah, so if there's a tie, we want to pick the one with more remainings, right? and then we can just, do we want to heapify or do we want to sort? I think heapify makes more sense because oven, but I think it also doesn't matter. I think it doesn't matter. So pairs.sort, reverse equals true, because we want to pick the biggest one. Okay, so yeah, we want to sum, wait, okay, so total remaining, that will equal the sum of our remaining. Current capacity equals 0. So in a range of that, if current capacity is greater or equal to total remaining, then we can break. Otherwise, cur in bottle. So our cur cap can plus equal our pairs at I, since it's sorted, and we want to pick the first, and then the second one will be the ones that are in our bottle, in bot, right? And then, yeah, and then we have the amount of bottles that we have. Oh my god. And then, yeah, and then we can just print our cur cap count. Cur cap count. Oh, cur cap count. And our total remaining minus the ones in the bottle. And then hopefully that's it. 2611. 2611. Please work. Yes. That's beautiful. That's beautiful. Oh, thank God it was an easy one. Oh, this works now. Since when? Oh. Success. Oh, I didn't choose a file. I'm stupid. Well, what? Oh, this is for prosperity. Should be a long ass name right there. That's great. Oh, thank God that they fixed that. Please work. Please work. Please. Please. Are you serious? Well, let's think about it. I mean, you're sorting it, and you have that total sum. You want to pick the one that has more stuff in it now, because then you don't have to pour that again. Oh, but does it sort it like that? Python dot sort tie. Oh, tie breaker. Yes. X. Okay, I'll do this. So for x, we want to do x at 0 and x at I. X at 1, sorry. Then I think that's why, because the tiebreaker probably isn't fully correct. Please. No. Are you serious? Are you serious? Is this really not a greedy problem? Is this... I mean, if you have... I guess we're not sorting by... We're sorting by, like... Yeah, I'm not too sure. I think this is when, the savior himself, ChatGPT comes in. Where is the tab? Oh my god. Yeah. Oh, so this is actually dynamic programming. Wow. Okay. Yeah, that's what I was kind of thinking. Cause like with my case, it's like you maximize the amount of volume, but like sometimes you don't really like. Sometimes it's more beneficial to pick like let's say you're picking 2 bottles and the total volume was 11 versus picking 2 bottles where your total volume was 10. If like the amount of units you need to pour is actually like only 10 and not 11, it makes more sense to pick the bottles that fit 10 if they have more soda inside, so you have to pour less soda. So I'll do that tomorrow. I will do that tomorrow. It's okay, bro. I'll do that tomorrow. That's it for today, bro. Okay, see ya.